About a week ago, YouTuber Nighthawk and Light provided a potential formula for making starlight. Starlight's a substance which was reportedly heat resistant up to 18,000 degrees Fahrenheit. Just for some context, the surface of the Sun is nearly half that temperature, at 9,940 degrees Fahrenheit. The original formula for starlight had been lost. We don't know the upper limit of the formula that Nighthawk and Light provided, so in today's video we're going to test that against thermite. We'll also test how it could be used in a backyard foundry. First, we'll start with making Nighthawk starlight. The formula is some amount of cornstarch. The amount is up to you at this point. The other components will depend on how much cornstarch you select. Here I'm using 4.8 ounces. Next, add baking soda. The amount should be around 10% by weight of what you selected for cornstarch. If you're making the same size batch that I'm making, that would be a half an ounce. I'm pre-mixing it because when you add the binder, the mixture will become very thick, and you might have pockets where the baking soda is absent. Optionally, also add a tablespoon of salt to prevent mold while the starlight's in storage. Ultimately, the starlight will need to be kept dry, and that'll be explained later on. Then add the glue. Here I use 2 of these school-sized bottles of Elmer's glue. Now it's time to mix it all up. If you have too little glue, it'll look like cheese curds. Adding more glue, it starts to look like chunky mashed potatoes. I'm shooting for creamy mashed potatoes as I want it to self-level to form a brick. Tap the bowl for several minutes to remove bubbles and pop any that rise to the surface. Or better yet, use a vacuum chamber. I'm baking it in the oven to speed up drying. Baking it at 200 degrees Fahrenheit for 3 hours will create a foam. Cooking it for 5 hours or more at the same temperature will create a tile. If you didn't use a vacuum chamber, you might find a rising prominence like this when you take it out of the oven. If this happens to you, just compress it. It's a very pliable material in the foam state. It feels like bread without much leavening. It's like a thick pita. If you didn't line the container, freeze it solid to harden it so you can remove it without tearing it. I've done it both ways and prefer lining the bowl with parchment paper. As a bonus, there isn't much left in the bowl to clean up. So now we'll need to test it with some thermite. Here's the formula that I'm using. 3 parts red iron oxide and 1 part aluminum powder. Put the lid on the container and shake it up to mix it. In my first test, I pre-burned the surface of the starlight to build up a protective carbon layer. I wanted to give starlight the best possible chance of surviving against thermite. Contrary to what you'll find all over the internet, propane can be used to set off a thermite reaction. The propane torch temperature is 3,623 degrees Fahrenheit. I wasn't able to find an exact ignition temperature for thermite, but it's somewhere around that temperature for the formula that I'm using. Note that you'll need to keep the propane on the thermite mixture for about 40 to 50 seconds to trigger the ignition. I don't recommend using it to ignite thermite. You have to be quite close and the ignition happens without much warning. That said, I ended up doing it twice in this video. The starlight brick that I tested was around 1 inch thick. After facing off against the thermite, 1/8 of an inch was converted to that protective carbon foam and carbon dioxide. And the starlight survived. I then tested the untreated side. This means that the thermite will be in direct contact with the starlight without that intervening carbon foam layer. And starlight wins again. As promising as this material is, there are some drawbacks. This formulation does not hold up well in the presence of water. For example, after soaking the tile for less than a minute, it begins to soften to the point where I can compress it, crumble it, and scratch it with my fingernail. With some caveats, Starlight might be useful in dry environments like outer space. But it wouldn't do in firefighting applications, as water is likely going to be used to put out the fire. And the dry tile is also very brittle. Altering the formula or making some kind of a composite can broaden the scope of the application. If you have a backyard foundry, you're probably thinking about using it as a refractory replacement. Because we're talking about low-cost materials, you could line your entire chamber for a few dollars. As a test, I made a replacement lid out of Starlight. Because the tile is so brittle, this time around I baked it into a foam, reinforced the interior with 2 layers of aluminum screen mesh, and added handles using a coat hanger. As expected, it held up quite well and the top of the lid was not hot after the melt. There will be about 1/8 of an inch shrinkage when it's exposed to the flame. Despite the charred state at the bottom of the lid, there is no damage to it. It's just a superficial carbon layer. Because you can make only what you need, it's more cost effective than Kaowool, Firebrick, or refractory cement. It also has a higher heat rating than those materials. And it's lightweight and formable. It isn't the exact formula of Starlight, so what should we call this? Nighthawk Starlight? Nightlight? Starchlight? Whatever we call it, I suspect we're going to be seeing a lot more heat-resistant products in the near future. Big thanks to Nighthawk and Light. His video's in the description below.